Hello, everyone, and welcome to our educational session. My name is Paul Arsov, and I'm the founder of the Decentralized Web project. But I like to talk about our projects, this one and other projects that we're working on in the end of this presentation. And coming back to the topic of this presentation, it's energy footprint of AI, current state, and alternative paths. This is part one of the presentation, and it touches on a little bit on psychology, it touches a little bit on technology, and also it is a hypothesis or theory of what AI could be and could achieve. And first, we're going to start with a story. In 2002, 31 years old person in Washington State in the US, he found himself in the threshold of becoming a genius. Leaving a bar in the evening, he was ambushed by two men who beat him and struck him unconscious. And when he came to battered and disoriented, he managed to put himself like to call for help and went to a nearby hospital. And in the following days and weeks, this person began to perceive the world in entirely new dimension. Things like swirling water or clouds appeared as intricate lines and grids, and he began to see everything as a canvas of a complex mathematical structures layered in fractals and highly complex geometric shapes. Although he had no formal background in mathematics, this person had developed an intuitive grasp of very advanced concepts. He meticulously sketched these shapes by hand, and after he healed from his brain injuries, he had emerged as a math savant, equipped with a rare, almost mystical insight into the hidden architecture of nature, space, and time. These brain injuries, the person in the story we mentioned, expose one of the nature's secrets. Our brain is designed to separate certain parts and keep them quiet. But when those boundaries break, when normal routes are closed off, our brain adapts. It forgets and what has been forbidden and forges new paths, allowing areas that usually work alone to join forces. The result can be astonishing, with abilities that seem to other people almost supernatural. It is a testament to how the brain raw resilience and power to adapt and survive. This dampening and separation is called inhibition, and it is a defining feature of human brains. Some researchers suggest that it provides the necessary distance to step back from the world and think before we act. By suppressing neural circuits It acts as a resource manager to reduce energy consumption and noise, provide signal clarity, and allow key areas to execute in complex sequences. So if we come back to the AI and technology, the current AI models, including the one behind ChatGPT, they lack inhibition. They do not suppress and keep activities apart like our brain does. Rather, they generate outputs based on probabilistic predictions from very vast amounts of secondary data derived from external sources. This makes them power hungry, clunky, and unable to learn independently and by themselves, and to learn on the fly, most importantly. But new brain-based AI models can now emulate certain aspects of inhibition. They are far more energy efficient and can learn from primary data collected directly from the real world. They don't need to be retrained or constantly overseen by humans, and they can adapt on the fly. As the cost to brain and to train and execute AI continue to skyrocket, these new models are increasingly viewed as a less expensive, viable alternative. But what will guide their behavior and decisions as they become more powerful? How will we control them? And actually, can we control them? So we're coming to the AI energy problem. The energy intensive transformer model dominates the AI landscape, commanding nearly all major investments in generative AI to date. Leading players such as OpenAI, Google's DeepMind, and Anthropic have poured resources into advancing this architecture, betting on its unique capacity to handle complex tasks. Google, for instance, has doubled down on its commitment to transformers, asserting that with enough reasoning layers, these models could, in theory, solve almost any problem. This vote of confidence underscores the sweeping ambition behind transformer technology and the belief that it will unlock the full potential of AI. The remarkable surge of investment in transformer models can be traced to three pivotal forces shaping the tech landscape. First, transformers have proven uniquely capable of handling vast volumes of secondary data, scrapped text, images, and videos, making them indispensable for high-stakes tasks such as language model and visual processing. Second, the influx of capital into AI, indirectly fueled by over a decade of central bank stimulus, which left venture capital firms and corporations flush with funds and reaching for yield. In the market, this has lacked true innovation for years. These funds naturally gravitate towards AI, with transformers at the forefront. Finally, the software industry saw a major shift in 2023 as software as service growth stagnated amid uh, tighter budgets and slowed sales cycles. In this more cautious environment, companies have turned to automation, eager to capitalize on AI models that promise not only productivity boosts but also direct replacement of human labor. As some people point out, um, like the future lies not in traditional software seeds, but in AI that effectively takes the seed itself, redefining roles once thought essential and that could be done only by humans. However, cracks are starting to appear in the transformer model's foundation. Its insatiable energy demand is raising red flags. By some estimates, data centers could draw up to 21% of world's electricity supply by 2030. And tech giants such as Apple are signaling caution with recent research suggesting that large language models may be approaching a performance ceiling. This tension has tech leaders exploring alternative energy sources, nuclear, even fusion, and searching advancements in model efficiency, quantization, and speed. Even quantum computing has emerged and entered the conversation as a possible solution. As the limitation of transformers models grow more evident and pressing, the market sounds poised to embrace sustainable, energy-efficient alternative. Um, Brain-based models address three core issues with current AI models. The first one is energy efficiency. Brain-based models are estimated to be 100 to 1000 times more energy efficient, employing decentralized sparse processing. The second thing is use of primary data. Unlike transformers, brain-based models can learn from direct real-time interactions. This enables them to build richer, context-aware understandings of their environment, a leap forward from the static datasets that transformers depend on. And the third thing is self-learning. Grounded in primary data, brain-based models can self-learn and adapt without needing constant retraining. Transformers, in contrast, rely on proxy scores and self-generating corrections, limiting their understanding to patterns rather than meaning. Once the system can truly self-learn, that process can be made recursive, which could quickly lead to extremely advanced AI. But hold out a thumb out at arm's length. That thumbnail is only part of your visual field where your eyes can sharply focus, courtesy of the foyer in our eyes, the tiny region of the retina dedicated to central vision. But the brain isn't content with such a limited view, so it improvises. Our eyes constantly flicker with quick, subtle movements called saccades which scan the scenes in fragments. Our entire visual field spans 210 degrees horizontally and 150 degrees vertically. The outer regions of our retina are packed with rod cells which detect light, motion, and contrast, especially in low light conditions, forming the basis of peripheral vision. Cone cells concentrated in the fovea but distributed across the retina aid in color vision and detail across the visual field. The real magic unfolds in the brain's visual cortex, nested in the occipital lobe. Here, fragments of visual data are stitched together to form a smooth, subtle image. In essence, visual perception is a clever series of approximations drawn from imperfect inputs, yet it delivers a remarkably seamless experience and uses very little energy. How human vision works is an introductory course on how new brain-based AI model could function. In 1992, Jeff Hawkins did what many PhD rejects dream of. He founded a successful tech company called Palm Incorporated. That would revolutionize mobile computing with Palm Pilot. But while the world has been captivated by its sleek pocket-sized device, Hawkins' mind was on something deeper, admittedly the neocortex. It unfolded the human neocortex world, cover an area roughly the size of a large cloth dinner napkin. This thin, wrinkled outer layer of the brain governs high-order functions like sensory perception, complex cognition, and motor control. At just 2.5 to 4 millimeters thick, roughly the thickness of two stacked pennies, it holds around 16 billion neurons and makes up about 75% of brain's volume. The Hawkins had a theory related to his rejected 1986 PhD thesis at Berkeley that the neocortex can be uniformly mathematically modeled. Hawkins stayed in the background for decades, more recently researching at his new company, Numenta. Then in 2021, he published 1,000 Brains, a new theory of intelligence, laying the neocortex-based AI models. The 1,000 brain theories of intelligence represent a bold departure from today's AI frameworks. Rooted in the concept of hierarchical temporal memory, this model belongs to the burgeoning class of brain-based approaches that aspire to mimic the human brain's inherent efficiency. And with this said, I will be ending part 1 of this presentation. Stay tuned for part 2 of the presentation, which is going to come next week. And with this said, I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov, and I like to mention of several projects that we are working on currently. The first project that I want to mention is Decentralized Web project. It builds a decentralized communication and advertising platform. And when we talk about decentralization, most people think of blockchain technology. But with this project, we insist that blockchain-based technology has many fundamental flaws and cannot be a driver of decentralization. The essence of decentralization is direct communication from user to user without going through a third party, namely a web server. With this direct communication, the users can be independent from going through other parties and pull information from other users which gain and store their own personal websites and their own offers of products, services, or social profile. And this decentralized web project, it is monetized through advertising, and it has its own blockchain instance, and it has crypto coin which rewards installing and being a user in this decentralized web project and ecosystem and platform. With this said, I would like to tell you the name and the URL of this project. It is decentralizedweb.org. Decentralized web, these are two words which are typed all together, decentralized and web. Then there is dot, and it ends with org. Once again, decentralizedweb.org. With this said, I'm ending introduction of this first project. The second project that I like to mention is the 3D NFT collection and a marketplace for objects based for 3D objects which are defined as non-fungible tokens. What is unique, special, and about this project is ordinary creators of 3D NFT objects, they rely on standard software which loads and displays the 3D object. Currently, there are two popular choices of standard software for displaying of 3D objects. One of them is called, both of them are game engines. One of them is called Unity, the other one is called Unreal. But from the very beginning of this 3D NFT project, we decided to build our own 3D software engine, and what it does, it is our 3D software engine, it reads the file of the 3D NFT object, then it opens a window on a computer screen, it loads the 3D object, and it starts animating in a way of moving it in a random fashion around the window. But in addition to these basic capabilities of reading the file, opening a window, displaying of the 3D NFT and animating of the 3D NFT, our 3D software engine has multiple additional capabilities. The first additional capability of the 3D NFT is the capability of speaking. The 3D NFTs can speak in one of three different voices. The 3D NFT can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken in a normal speed manner, or in a fast speed manner, or in a slow speed manner. If we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a masculine person or the voice of an old person. If you, on the other hand, we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. The second additional important capability of our 3D software engine is the capability of voice recognition. Like for example, we have a 3D NFT which is moving in a constant fashion around a window, then we can issue our very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. Then we can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go farther away, zoom out, and start rotating. The third additional and important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply in few sentences of who they are. You can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or about decentralization or about the country called Russia. The last additional but important but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. Like when we display the 3D NFT in a way of stereoscopics, then one part of the 3D NFT is displayed in red or reddish colors, and another part of the 3D NFT is displayed in a blue or bluish colors. Then you can come to the our website, and probably now is the time to tell you the name and the URL of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're typed all together, decentralized web. Then there's dot and it ends with org. Once again, 3D NFT dot decentralized web dot org. On the top of the main page and every other page, there are a number of links. One of these links is the link to accessories. When you click on this link, you're going to see that we are offering special glasses. When you order one pair of these glasses and receive these glasses, you can put these glasses on. You can request displaying of the 3D NFTs in a way of stereoscopics, and then you are going to see the 3D NFT in real 3 dimensions coming out of the flat 2-dimensional computer screen and being displayed as I mentioned in 3 dimensions. With this said, I'm ending talking about our 3D NFTs, and I like to and 3D software engine, but I like to mention a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance. This blockchain instance runs Ethereum software, and it is the same software which runs on Ethereum mainnet, it runs on Binance Smart Chain, it runs on Polygon Matic Chain, it runs on Avalanche AVAX chain, and it runs on many other famous or not famous blockchains. By having our own blockchain instance, then we do not require our users to pay gas fees for deployments of the smart contracts of non-fungible tokens, and our users do not pay gas fees for transactions of transfer of ownership from one user to another user. In this way, we are detaching our 3D NFTs from a single crypto coins, and we allow payments buying and receiving proceedings from sales for our 3D NFTs in multiple crypto coins. Currently, the choices of coins for buying and selling of our 3D NFTs include Solana Sol, it includes Polygon Matic, it includes Avalanche AVAX, and it includes KCS, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and selling with crypto, we have a second parallel and independent way for buying and selling of 3D NFTs, and it is done entirely in fiat currency. Like if you're a user, you come to our 3D NFT marketplace, you browse through the collection of the 3D NFTs, you click and select one 3D NFT that you like to purchase, then you're going to be presented with a screen where you can select between payments with 4 crypto coins, 4 choices, and a 5th choice of paying with fiat currency. So let's say you select paying with fiat currency, then you're going to be asked to put the number of your debit or credit card, expiration date and CVC, and when you click on the button to complete the transaction and make the payment, what is going to happen and is there is going to be a transaction and conversion from your national fiat currency to US dollars, and the payment is going to be deposited in our bank account. Then we're going to follow this action with the second action and transfer of the initial ownership from the 3D NFT from our marketplace to you, and now you become owner of this 3D NFT. You can play with this 3D NFT for a while, then you can decide to put the 3D NFT for sale. You decide on the price that you want to put for sale, and then you can the 3D NFT is going to be listed on our 3D NFT marketplace for sale. So let's say this second user, they come to our 3D NFT marketplace, they browse through the 3D NFTs, they see and they like the 3D NFT that you put for sale. Then they go through the same steps of selecting between payment with crypto coins or payment with fiat currency. So let's say they select also payment with fiat currency. They go through the same steps of putting the number of their debit or credit card, CVC expiration date. They click on the button to complete the transaction. So what is going to happen is there is going to be a transaction and conversion from the national fiat currency of the second user, which could be different than US dollars, and it could be different than your national fiat currency. And this transaction is going to be deposited in our bank account in US dollars. Then we are going to follow this action with a second action and transfer of ownership from you to the second user, and now the second user becomes owner of this 3D NFT. And finally we're going to make a third action and a transfer from our bank account, convert the payment for the sale of the 3D NFT from US dollars to your national fiat currency, and deposit this amount of national fiat currency in your bank account. With this said, I'm ending talking about this second project. I like to mention the third project that we work on. The third project is related with electric vehicles and with charging of these electric vehicles. With with this set, what we are building is a product or like a group of products which include high voltage and high current electric switch, which could provide electric power to the electric vehicle. This switch is controlled remotely through Wi-Fi communication, and the product is equipped with Wi-Fi communication, which could have both sides as an access point and as a user, which connects also to another access point. The products that we're building also contain currency measurement device, which could measure the energy consumed while charging of an electric vehicle. Then our product can calculate the total energy consumed, and it can bill read the user. And our product contains also a near-field communication reader, which could identify a user by their debit or their credit card, or like the near-field communication token in the form of a credit card, or near-field communication in token in form of keychain token, or near-field communication device in the form of ring which the user can wear. With this said, how do we anticipate the charging of electric vehicle to be? We anticipate that current model, which is like resembling internal combustion engine charging, it resembles the way internal combustion engines, they go to a gas station, they pick the hose of pumping column, they connect the hose to their vehicle, to the gas tank of their vehicle, they start loading fuel, they identify themselves to the pumping station with their debit or credit card, and after they're done with loading fuel, they're charged for the fuel they did pump into their vehicle, and then they leave the gas station. In the same way, there are electric charging stations with a number of columns which has cable which the owner of an electric vehicle, they come to this location of charging station, they connect the cable to their electric vehicle, they identify themselves with their debit, credit card, or near-field communication credit card, keychain token, or ring, and they start loading energy in their electric vehicle. They stay for a while at this charging station. Then they, when they're done, they leave their charge for the energy. They load it in their electric vehicle, and they leave this charging station. But with the exponential growth of electric vehicle, we estimate that the number of charging stations is going to become ultimately insufficient to handle this exponential growth of electric vehicle. What we are proposing, and we actually wrote an article about this, which provides lots of details about this. We propose a model instead of gas station model. We propose a model which is based on a parking lot model. Many users, they live in high-rise buildings, and these high-rise buildings, they have ground floor where the users can park their vehicle, or they have multiple underground floors of one parking lot where users can leave their vehicle in the evening, during the night, and early morning. So we propose and we're building products which can be mounted in the parking lots, and they could handle charging of multiple electric vehicles. The user, when they come to their parking lot in the evening, they can connect the electric cable, they can identify themselves to the charging station, they can start like loading energy, and when they come in the morning, they can disconnect the cable from their electric vehicle, and they can leave with their electric vehicle loaded with energy during the evening, night, and early morning. In the same way, users who come to their workplace, they may be working in a high-rise office building which has a ground floor parking lot or multiple floors of underground parking lot. In the same way, when the user comes in the morning to their workplace, they can connect cable of a charging station which this office building parking lot has been outfitted with, and they can start loading electric energy to their electric vehicle during the morning, afternoon, and even early evening, while they're at their place of work. With this said, I like to mention that the products that we're building on has very important additional capabilities. They have communication between each other, and they have the capability of communication with the central point and central station, which can accumulate the electric energy consumed by the different charging stations. This central point can aggregate these values, and this central point can report these values to the utility company. This is a very, very important capability for the electric utility because the electric utility has at any time to balance the number of the total energy generated with the total energy consumed. If there is some disbalance between these two values, generation and consumption, on one hand we can have inefficiency and wasted energy, and on the other hand we can have like insufficient energy generated and blackouts to like specific neighborhoods, whole cities, or whole regions because of the insufficient energy being generated. So with this said, I like to mention the URL and the name of this website that we are building products. It is power.rstack.com. Power is the ordinary word for power, then there is dot, then there is a word which sounds like rstack, which I can spell it letter by letter. It is Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether it sounds like rstack, then there is dot, and it ends with com. Once again, power.rstack.com. With this said, I'm ending talking about the third project that we work on. I like to mention the fourth project that we work on. It doesn't have a website yet, but we're going to build soon website which are going to offer the details about this project. And the project is about building intelligent devices which include like basic artificial intelligence. It includes vision, they include motion, and they include multiple other capabilities which they can present to user, and the user can have the capability to control these intelligent devices which are going to be autonomous. These intelligent devices are going to be given tasks, and these devices are going to fulfill these tasks independent from human control and interaction, but the human can supervise the fulfillment of these tasks and have a say and have a control over the execution of the separate tasks of these intelligent devices. So what we are currently working on is camera, which like camera and vision, and automatic detection of objects, definition of objects and detection of objects, and camera vision, which can be outfitted to scan their environments, and this camera also can be outfitted with 3D displaying capabilities and 3D visioning capabilities, which can measure distance to objects. With this said, I'm talking about this fourth project, and I'm ending this presentation. Stay tuned for part 2 of this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.